Hello, I am Professor Deepak Bhoge. Welcome you in my eConcept channel. In this video, I will talk about heat engine, its definition, working and few examples. Now, heat engine is a device which converts heat energy into mechanical energy. Now here we have taken one example in which after combustion of a fuel, heat energy will be produced, and in heat engine that heat energy is utilized for doing some mechanical work. Now here that heat energy is utilized for movement of these pistons. So this heat energy is converted into the reciprocating motion of the piston. Now for analysis purpose, heat engine is shown in the block diagram like this. Now in this block diagram, the source of heat energy is taken at a high temperature T1, from which Q1 amount of heat is given to the engine. Out of this Q1 amount of heat, some heat is utilized for doing W amount of work, and remaining heat is rejected into the atmosphere or surrounding at a temperature T2. In this block diagram, T1 is called as a source temperature, from which Q1 amount of heat is given to the engine. T2 is called as a sink temperature, at which Q2 amount of heat is rejected by the engine. Now this heat engine works on the Carnot cycle, and this Carnot cycle possesses 4 processes, and those are 1 to 2 is isentropic expansion in the expander, generally we call it as a turbine. 2 to 3 in which 2 to 3 is the isothermal heat rejection in the condenser or heat exchanger. 3 to 4 is the isentropic compression in the compressor, and 4 to 1 is the isothermal heat addition in the combustion chamber or heat exchanger. Okay. Now this Carnot cycle is shown in a block diagram, or you can see the working of the Carnot cycle in the block diagram. Now here 1 to 2 is the turbine or the expander, in which we are getting the work output. 2 to 3 in which heat is rejected into the surrounding or atmosphere by condenser or heat exchanger. 3 to 4 is the isentropic compression in the compressor, and 4 to 1 in which it is a combustion chamber isothermal heat addition in the combustion chamber or heat exchanger. In the competitive exam or some interview, the questions will be asked such that what is the sequence of operations in the Carnot cycle, or what is the sequence of the parts in the Carnot cycle. So at that time you are able to explain the working and the sequence of the operations and the sequence of the parts in the Carnot cycle. Now here there is one homework. Can you draw this Carnot cycle on the PV plane? Now how to find out the performance of any system? Now in this case it is a heat engine. So how to find out the performance of heat engine? While calculating performance, first we should know what is the input and the output. Now this in the heat engine, input is the Q1 and output is the W. So the performance of the heat engine is the output divided by input. So that is W divided by Q1. If you apply the first law of thermodynamics at the engine, so if you observe at the engine, so incoming energies are Q1 and outgoing or leaving energies from the engines are W and the Q2. So according to the first law, input energy is equal to output energy. So Q1 is equal to Q2 plus W. So W is equal to Q1 minus Q2, and if you substitute in place of W as a Q1 minus Q2, we are getting efficiencies Q1 minus Q2 upon Q1, and if you cancel Q1 by separating Q1 and Q2, then Q1 get cancelled, then efficiency becomes 1 minus Q2 upon Q1. Then we according to the Kelvin scale that we will see later videos, but according to the Kelvin scale we can write Q2 by Q1 is equal to T2 by T1. This equation is valid for the reversible process, and in Carnot cycle all the processes are reversible. So for Carnot cycle or Carnot engine we can write Q2 by Q1 is equal to T2 by T1. So this is called as a Kelvin scale, in which T1 and T2 are the absolute temperature that are measured in the Kelvin. So finally efficiency becomes 1 minus T2 by T1. Here we have replaced Q2 by Q1 as a T2 by T1. So from these equations it is clear that efficiency is a function of T1 and T2, that is the higher temperature and lower working temperature of the cycle or engine. So while calculating, you should remember, while calculating efficiency of a Carnot engine, always take the temperature in Kelvin. So these are the examples of the heat engine. Now this is a thermal power plant in which the combustion of a fuel takes place in the boiler, and where water gets converted into the high pressure high temperature steam. That steam is utilized for rotating the turbine blades. So here this heat energy is utilized to rotate the turbine blades. So heat energy is converted into the mechanical work. So thermal power plant is the best example of a heat engine. Another example we have seen in day-to-day life, you can see, that is automobile engine, in which combustion of a petrol or diesel takes place in the combustion chamber, and where high pressure uh, gases will be produced, exhaust gases will be produced, or combustion products will be there, which will move the piston in the downward directions, and it will produce the mechanical energy. One easy MCQ we have taken: a Carnot engine works between 600 Kelvin and 300 Kelvin. What is its efficiency? So we know the efficiency formula of a Carnot engine is 1 minus T2 upon T1, where T2 is a low temperature 300 Kelvin and T1 is the high temperature, that is 600 Kelvin. So efficiency becomes 0.5, or that is 50%. If these temperatures are given in degrees Celsius, then we need to convert it into the Kelvin. Now in this problem they have already given it is in Kelvin. If it is given in degrees Celsius, first convert it into the Kelvin and then find out the efficiency. Now these are the reference used.